According to the National Electrical Code, specifically Section 250.92b2, the question of whether bonding bushing is required on a metal nipple connecting a meter enclosure to a main panel depends on how the nipple is connected and bonded. The code stipulates that if a metal nipple connects an enclosure or equipment to a threaded hub or a lug, the bonding must occur at the threaded hub or lug. The bonding jumper used must adhere to the sizing requirements outlined in 250.102. In the scenario presented, a metal nipple joins a meter pan to a main panel. The nipple is connected to the panel via a threaded hub that is bolted to the top of the rain-tight panel. This connection to the threaded hub serves as the primary bonding point. Since the nipple is bonded at the threaded hub, NEC 250.92b2 indicates that an additional bonding bushing at the meter pan end of the nipple may not be necessary. The code prioritizes bonding at the point where the nipple connects to the threaded hub. However, it's crucial to recognize that electrical inspections often involve multiple considerations and interpretations of the code. While 250.92b2 seems to support the argument that a bonding bushing is not required in this specific setup, an inspector might have identified other issues that led to the failed service. It's imperative to engage in a dialogue with the inspector to understand the full scope of their concerns. There might be local amendments to the NEC, specific interpretations adopted by the jurisdiction, or other factors that influence the inspector's decision. To ensure compliance and resolve the issue, it is highly recommended to directly communicate with the inspector. Ask for clarification on the specific reasons for the failure. Understanding the rationale will allow you to address the concerns effectively and ensure that the installation meets all applicable requirements. In this situation, you installed a temporary 120V/240V service. This service included a meter and the main panel connected by a metal nipple. The nipple was inserted into a concentric knockout in the meter pan, secured with a lock nut and a plastic bushing. At the panel end, the nipple was connected to a threaded hub bolted to the top of a rain-tight panel. The electrical inspector disapproved of the service, stating that a bonding bushing was needed in the meter pan. He referenced 250.92b2 of the National Electrical Code, suggesting that the nipple's bonding at the hub end should negate the need for a bonding bushing at the other end. You are likely correct based on a direct interpretation of 250.92b2, which focuses on bonding at the threaded hub. However, the inspector might have other concerns beyond this specific code section. Always verify the inspector's complete reasoning to ensure full compliance with all applicable codes and regulations. Further considerations should involve examining the grounding and bonding system as a whole, confirming that all components are properly sized and installed according to the NEC. Also, ensure that the equipment grounding conductor pathway is continuous and effective. Consider factors like the type of metal used for the nipple, the tightness of the connections, and whether the lock nut and plastic bushing provide adequate grounding continuity at the meter pan end. The inspector might be concerned about the overall integrity of the grounding path, even if the primary bonding is at the hub. Review the general bonding requirements in Article 250 of the NEC to gain a broader understanding of the principles involved. This includes ensuring that all metallic parts are properly bonded to create a low impedance path for fault current. If there are any doubts about the interpretation of the code or the inspector's requirements, consult with a qualified electrical engineer or another experienced electrician who is familiar with local codes and practices. They can provide an objective assessment of the situation and offer recommendations for achieving compliance. In summary, while 250.92b2 supports the argument that a bonding bushing may not be required at the meter pan in this specific scenario, it's essential to understand the inspector's complete reasoning and address any other potential issues they may have identified. Communication, thoroughness, and a commitment to safety are key to resolving the situation and ensuring a compliant electrical installation. Always prioritize safety and compliance with all applicable codes and regulations. The National Electrical Code, or NEC, is a comprehensive set of standards designed to ensure the safe installation of electrical wiring and equipment. Grounding and bonding are critical components of electrical safety, serving to protect people and property from electrical shock and fire hazards. Article 250 of the NEC provides detailed requirements for grounding and bonding, outlining the methods and materials that must be used to create a safe and effective electrical system. Grounding refers to the connection of an electrical circuit or equipment to the earth. This connection provides a low impedance path for fault current to flow back to the source, causing the overcurrent protective device, such as the circuit breaker or fuse, to trip and de-energize the circuit. Grounding helps to limit the voltage on electrical equipment and prevent dangerous voltage buildup that could result in electrical shock. Bonding, on the other hand, involves connecting all metallic parts of an electrical system together to create an electrically continuous path. This includes metal conduits, enclosures, equipment frames, and other metallic components. Bonding ensures that all these parts are at the same electrical potential, minimizing the risk of electrical shock if a fault occurs. When a fault occurs in an electrical system, such as a short circuit or ground fault, current will flow through the grounding and bonding system back to the source. The effectiveness of this system depends on the quality of the connections and the size of the grounding and bonding conductors. Poor connections or undersized conductors can impede the flow of fault current, increasing the risk of electrical shock or fire. The NEC specifies the minimum size requirements for grounding and bonding conductors based on the size of the overcurrent protective device. These requirements are intended to ensure that the conductors can safely carry the maximum fault current without overheating or causing a voltage drop. In addition to conductor sizing, the NEC also addresses the methods for making grounding and bonding connections. These connections must be mechanically sound and electrically conductive, providing a reliable path for fault current. Common methods include using listed connectors, exothermic welding, and bonding jumpers. The NEC also covers the grounding and bonding of specific types of equipment, such as transformers, generators, and motors. These requirements are tailored to the unique characteristics of each type of equipment and are intended to ensure that they are properly grounded and bonded to prevent electrical hazards. One important aspect of grounding and bonding is the concept of the equipment grounding conductor, or EGC. The EGC is a conductor that connects the non-current carrying metal parts of equipment to the grounding system. This conductor provides a low impedance path for fault current to flow back to the source, tripping the overcurrent protective device. The EGC can be a wire, a metal conduit, or other approved means. The NEC specifies the requirements for the installation of the EGC, including its size, routing, and termination. Another important concept is the grounding electrode system. The grounding electrode system is the means by which the electrical system is connected to the earth. This system typically consists of one or more grounding electrodes, such as ground rods, metal water pipes, or concrete encased electrodes. The NEC specifies the requirements for the installation of the grounding electrode system, including the number and type of electrodes, their location, and the size of the grounding electrode conductor. In addition to the general requirements for grounding and bonding, the NEC also includes specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. These requirements take into account the unique electrical hazards present in each type of occupancy and are intended to provide an appropriate level of safety. Grounding and bonding are essential for electrical safety. By following the requirements of the NEC, electricians and electrical contractors can ensure that electrical systems are installed in a safe and effective manner, protecting people and property from electrical hazards. NEC 250.92 specifically addresses the bonding of metal enclosures. This section focuses on ensuring that metal enclosures containing service conductors are properly bonded to provide a safe and effective path for fault current. The requirements in 250.92 are intended to minimize the risk of electrical shock and fire hazards associated with metal enclosures. The general principle behind 250.92 is that all metal enclosures containing service conductors must be bonded together into the grounding electrode system. This creates an electrically continuous path that allows fault current to flow back to the source, tripping the overcurrent protective device. The specific requirements in 250.92 vary depending on the type of enclosure and the method of connection. However, The overall goal is to ensure that all metal enclosures are effectively bonded to provide a safe and reliable electrical system. One common method of bonding metal enclosures is to use bonding jumpers. Bonding jumpers are conductors that connect two or more metal enclosures together. These jumpers must be sized according to the requirements in 250.92 and must be securely connected to the enclosures using listed connectors or other approved means. Another method of bonding metal enclosures is to use metal conduit. When metal conduit is used to enclose service conductors, the conduit itself can serve as the bonding conductor. However, the conduit must be properly installed and connected to the enclosures to ensure that it provides a continuous electrical path. In some cases, it may be necessary to use a combination of bonding jumpers and metal conduit to achieve effective bonding. For example, if the conduit run is interrupted by a non-metallic fitting, a bonding jumper must be installed to bypass the fitting and maintain electrical continuity. The NEC also addresses the bonding of metal enclosures that are separated by expansion joints. Expansion joints are used to accommodate movement in buildings due to thermal expansion or contraction. When metal enclosures are separated by expansion joints, bonding jumpers must be installed to bridge the gap and maintain electrical continuity. In addition to the general requirements for bonding metal enclosures, the NEC also includes specific requirements for different types of enclosures. For example, there are specific requirements for bonding meter enclosures, service disconnect enclosures, and other types of enclosures that contain service conductors. These requirements take into account the unique characteristics of each type of enclosure and are intended to provide an appropriate level of safety. To ensure compliance with 250.92b2, it is important to carefully inspect all metal enclosures containing service conductors and verify that they are properly bonded. This includes checking the size and installation of bonding jumpers, the condition of metal conduit, and the tightness of connections. Any deficiencies should be corrected immediately to ensure that the electrical system is safe and reliable. Proper bonding of metal enclosures is essential for electrical safety. By following the requirements of 250.92b2, electricians and electrical contractors can minimize the risk of electrical shock and fire hazards associated with metal enclosures. The National Electrical Code is updated every 3 years to reflect changes in technology, safety practices, and industry standards. It is important for electricians and electrical contractors to stay up to date on the latest edition of the NEC to ensure that they are following the most current and effective safety practices. The NEC is a complex and comprehensive document, and it can be challenging to interpret and apply. Electricians and electrical contractors should seek out training and education opportunities to improve their understanding of the NEC and its requirements. There are many resources available to help electricians and electrical contractors stay up to date on the NEC, including training courses, seminars, and online resources. It is important to choose reputable and qualified providers to ensure that the training is accurate and effective. In addition to training, it is also important to have access to the NEC document itself. The NEC is published by the National Fire Protection Association, or NFPA, and can be purchased in print or electronic format. Having a copy of the NEC readily available allows electricians and electrical contractors to quickly reference the code when questions arise. Staying up to date in the NEC is an ongoing process. Electricians and electrical contractors should make it a habit to regularly review the NEC and attend training courses to stay informed of the latest changes and requirements. By staying up to date on the NEC, electricians and electrical contractors can ensure that they are providing the safest and most reliable electrical services possible. The NEC is not just a set of rules and regulations. It is a comprehensive guide to electrical safety that is based on years of experience and research. By following the NEC, electricians and electrical contractors can protect themselves, their customers, and the public from the hazards of electricity. The NEC is a valuable resource for anyone who works with electricity. It provides the knowledge and guidance needed to install and maintain electrical systems safely and effectively. By taking the time to learn and understand the NEC, electricians and electrical contractors can make a significant contribution to electrical safety.